Okay, I promised that I would give y'all a walkthrough of the naming flowcharts podcast. So if we are starting with a compound and we have the name, let's say we have phosphoric acid. So the first thing we're going to ask ourselves is acid in the name? The answer to this one is yes. So it is an acid. So you're going to have hydrogen in the formula. So go ahead and write your hydrogen there. Now the number of hydrogens is equal to the charge of what it is bonding to. So we have to continue looking to see how many hydrogens we're going to have. Is there hydro in the name? In this case, the answer to that is no. So that means we have a polyatomic ion in the formula. And so we have to look, and we see that ic acid means that we are looking for the 8 polyatomic ion. So we're going to look on the sheet, and we find out that the polyatomic ion for phosphate is PO4. It has a 3 negative charge, so we're going to have 3 hydrogens. Another example would be if we had hydrosulfuric acid. Okay, so we have acid in the name. The answer to that is yes, so we have an acid. We know we're going to have hydrogen. The number of hydrogens is equal to the charge, so we're going to come back to that. Is there hydro in the name? The answer to that is yes. So we're not dealing with any polyatomic ions for the most part. There's a couple of exceptions, but mainly you will usually look at your periodic table. So sulfur is S2 minus. That means we're going to have 2 hydrogens and 1 sulfur. Okay, to take you over to the other side of this chart, if we have dinitrogen, pentoxide. Okay, so we don't have acid in the name, so we've got a no over here. Are there prefixes? In this case, the answer to that is yes. That means it's a covalent compound, and the prefixes tell you how many of each element you have. So we have di, meaning 2, nitrogens, that's N2. Pent, meaning 5, and oxide is your oxygen. So N2O5. Another example is if we have magnesium iodide. There's not acid in the name, so we come over here. There's no prefixes, so that means we have an ionic compound, and so we're going to have to cross and drop the charges. We're going to look at the periodic table to find out what the charge symbols and charges are. So magnesium is Mg, and that's a 2+. Iodide means we're talking about iodine and not a polyatomic ion, and that's I with a 1-. There's 2 ways of looking at it. Between 2 and 1, the common multiple is 2. So in order to make 2 on the magnesium, we're going to have an Mg, and we only need 1 of them. But to have 2 as our common multiple on our iodine, that takes two iodines to make 2. So we have I2. Or the easier way of looking at it is the charge of the other thing is going to cross over and drop and make and tell you how many of the other element that you need. So to work from the other direction, we're going to look at some formulas. We have H3PO3. So does the formula start with hydrogen? In this case, the answer is yes. So it is an acid. Is it only 2 elements? No, it's not. So we're going to look at our polyatomic ion list. PO3 is phosphite. We look at whatever the hydrogen is bonding to, and that is phosphite. So the ite becomes us, and phosphite and sulfite, and phosphorus and sulfur are different. They end up adding some stuff back in, but you end up with phosphorus acid. Okay, another example on this side is if we have H3N. The formula starts with hydrogen, so yes, we have an acid. Are there only two elements? In this case, it is yes. So it's the hydrorootic acid. So we're going to have hydro. The root of nitrogen is NITR. Add ic acid. And that's how we name that one. Another example is CO2. It does not have start with hydrogen, so the answer to that is no. Does it contain two nonmetals? The answer to that one is yes. So we have a covalent compound. And prefixes tell us how much of each element we have. The first name is unchanged. We just name it. The second name ends in "ide," and our prefixes tell us how many we have. Going back to your previous notes to remember what your prefixes are. And we never use mono on the first element. So we have one carbon, so we just use carbon. And we have two oxygens. Two is di. Oxygen becomes oxide. And the last example, we have Pb3 ASO4 with a 2- charge. So, we started off with, at the beginning, does it start with hydrogen? No. Is it only two nonmetals? The answer to that is no. So we have an ionic compound, so now we have to look at it as polyatomic names are unchanged, metal names are unchanged, with the exception that if they're that large group that we covered, we're going to use Roman numerals to tell us what the charges are. And if we ended in nonmetal, we would change that ending to I, just like we do in our covalent compounds. So Pb is lead. We're going to need to write the charge for that, so I'm going to come back to that. ASO4 is arsenate. Well, just like on the previous slide where we crossed and dropped to know how many of each thing that we needed, we can uncross our charges, our subscripts, to find out what charge we started off with, and so that means that we have lead 2 arsenate. Hope this helps.